2 days ago, we talked about congruence transformations. What did the word congruent mean? Equal, equal size, same. Everything's the same. Same size, same angles, same everything. Okay? Today we're talking about similarity and transformations. So with the congruence transformations, we were talking about rigid transformations. Translations, reflections and rotations are all rigid, meaning they keep the same size and shape. Dilations are different because they're a non-rigid motion and it preserves the shape but not the size. So the angles are the same, but the size is much bigger or much smaller. So this is what we're writing in our first box. A dilation is a non-rigid motion. It preserves shape but not size. Yep, in that very first box. Keeps the same. If you don't want to use the word preserves, you can change it. A lot of times if you put your word in, things in your own words, you remember it better. So don't copy this just to be copying it. Make it your own. Okay? We know that two geometric figures are similar figures, not congruent, but similar figures, if and only if there is a similarity transformation that maps one figure onto the other one. So we get similar figures if and only if a similarity transformation takes one to the other. And finally, similarity transformations are going to be defined as dilations or a composition of a rigid transformation and a dilation. So to get a similarity transformation, we either have to use a dilation or a dilation with a translation, reflection, or rotation. Questions on this slide? Okay. All right, so let's put this into motion. So the first example, I'm going to ask you to graph triangle FGH. And F has vertices at 1, 2. So put F at 1, 2, and make sure you label it. Because when we're taking our test on Tuesday of next week, if you don't label the points, I'll have to take off a point. Okay? So graphing the triangle gets you 3 points, 1 for graphing each point correctly, and 1 more point for labeling them properly. Then G is going to be at 4, 4. And H will be at 2, 0. So when you're finished graphing in that triangle, it should look like mine. Then we're going to do two things with it. The first thing we want to do is reflect it. Okay, reflection's listed first, so we reflect it in the x-axis. What does that mean, Josh? Good, we're taking it across that horizontal line, the horizontal axis. So where does H go? It stays, so label that H prime. Where is G going? That 4, 4, so it will be 4, negative 4, because we switch them, right? We switch the y-coordinate to be a negative, the opposite sign. And then where is F going? 1, negative 2. Okay. Make sure you label them H prime, B prime, and F prime. Okay. Now we're ready to dilate. And we're dilating our new image. Okay, the one we just graphed with all the primes. So if we're dilating it and it says we're taking xy to 1.5x, comma 1.5y, what's our k? That is the k. 1.5 is our k, right? So are we making it smaller or bigger? Bigger, okay? 1.5 times as big, right? Okay, so if we take each of these points times 1.5, our new g prime, when we take 1.5 times 4, we're going to get 6, negative 6. And that's g double prime. Positive 6, negative 6. Took 1.5 times both of those values. Okay? H prime was at 2, 0. If we take it times 1.5, what's 2 times 1.5? 3. And 0 times 1.5. So H double prime is 3, 0. So plot that and label it H double prime. It is. It didn't move much. And then our point F was at 1, my F prime was at 1, negative 2. So where's F double prime going to go? Yeah, 1.5, comma, negative 2 times 1.5 is negative 3. So when you're finished and you connect the dots, they should have the same shape. Not the same size, but the same shape. Okay? It should look like that. Slightly larger than the previous one that we reflected. Questions on this one? Okay, feeling good about this one? All right. Next one. Now we're in the next box in your notes, and we want to know what's the similarity transformation that takes trapezoid PQRS to trapezoid WXYZ, the blue one to the green one. Looks like it could be a 180 rotation, okay? Or we could flip it across the y-axis, okay? If you see that the rotation is going to twist it, and then we'd have to flip it again, okay? So I think our better bet is to, and we can do it with a rotation. It just takes 3 transformations to do it instead of 2. Okay, so there's no one right answer to these. You may do something completely different than the person next to you, and you can both be right. Okay, but I like the idea of reflecting first across the y-axis. So if we reflect it across the y-axis, where's R going? Stays put, right? On the y-axis, so there's our R prime. Okay, and then when we take it to the other side, the S reflected across the y-axis will be how many steps away? 6. So we keep the same height, but S prime is going over here. Okay. Where's P going? 6 steps away from the y-axis. So P prime will be over here. And then Q was at negative 3, 3. So where is it going? 3, 3, 3, positive 3, positive 3. So here's our Q prime. Okay, so that was a reflection across the y-axis. Almost there, but now we have to make it smaller, right? So what is our K? Well, Q prime P prime was how long? 3. How long is xw? I like 1/3. Let's check it to be sure. wz was 2, and 1/3 of 6 p prime s prime is 2. Okay, so our k is 1/3. So then we just say it's a dilation, and k is 1/3. Make sense? Questions about this one? Okay. Then the next one, our last one, bless you, is this one. Okay. Okay. So we think it might be a 180 rotation.
Yeah, 180 rotation, and then reflect over the y-axis.
Okay. So if we did a 180 rotation, then we probably have to do a reflection across the y-axis to get it in the right orientation, or we could potentially reflect it across the x-axis. Okay. So shall we try the reflection across the x, because it should take one less transformation, right? Okay. Let's try that. Let's see if we can get it in the same orientation. Okay. So if we reflect across the x, then and we're going from wxyz, okay, the small one, to the large one. So when we reflect it across the x-axis, it's dropping down, right? So my new one would be here, and this guy would be up here. And that looks like it's in the correct orientation for the green, doesn't it? Okay. So we reflected across the x-axis. W was one step away, so now it's one step down. X was one away, and so was Y. Good question. Okay, so how long is WX? 2, right? RS is 4, okay? Are we expanding or contracting? Expanding, so we want our K value to be a number bigger than 1, and we think that K value is 2, okay? A dilation twice as big. And we check another side. This was 1, and this is 2. So we have a dilation, and K is 2. Okay, questions on this one? All right, your assignment is to finish the rest of this sheet. You have 6 problems, and then start studying for your test. Go over your notes and so forth. We'll have a review on Monday, and then test chapter 4 on Tuesday. The dilation was 2. Yep, twice as large.